This is an answer to question 5 on the January 2013 S1 paper by OCR, and we're told we have a distribution X which follows B 5 1/4. So it's a binomial distribution with n being 5 and p being 1/4. In part 1 and part A of that bit, we're asked to find the expected value of x. For a binomial distribution, which is binomial np, the expected value of x is n times by p. That's just something you're expected to know. So that will be 5 times by 1/4, which is 1 1/4, 1.25 or 5/4. In part B, we're asked to work out the probability x is equal to 2. Well, because n is 5 and p is 1/4, that is in the stats tables you're provided with. So you might as well use the tables. And the probability x is 2 is the probability that x is less than or equal to 2. Take away the probability that it's less than or equal to 1. Now, as long as you find the right tables, the tables for n equals 5, and go down the right column where p is 1/4 or 0.25, you can get both of these values from your tables. The first value is 0.8965 and the second value is 0.6328. And when you do the subtraction, you'll get 0.2637. That now brings us on to part 2. In part 2 it says 2 values of x are chosen at random. Find the probability that their sum is less than 2. Well, the values that x can take are all the whole number values, all the integers from 0 up to and including 5. So if I'm adding 2 of them together, for the total to be less than 2, I either have a 0 and a 0, or a 0 and a 1, or a 1 and a 0. There are no other ways of doing it. If I have a 1 and a 1, I get a total of 2, which is less than 2. So I'm going to need to know the probability that x is 0, and I'm also going to need to know the probability x is 1, as 0s and 1s are what I'm interested in this question. Well, the probability for a binomial distribution is always n, choose r, and this is my r value, the number here in the bracket, p to the power of r, 1 minus p to the power of n minus r. Anything to the power of 0, anything choose 0 is 1. Anything to the power of 0 is 1. So this is just the same as 3/4 to the power of 5. And if we work that out, well, I'm not sure what that is a decimal. I'll leave it like that for the time being, but we could work that out. I'll get that as a decimal in a minute. This next one down here, x is 1 will be 5 choose 1, 1/4 to the power of 1, and 3/4 to the power of n minus 1, which is 5 minus 1, which is 4. And again, I can get that one as well. So if I reach for a calculator, I haven't got these worked out already. The first one is 3/4 to the power of 5, and as a decimal that is 0.2373. And this one down here, 5 choose 1 is just 5, times by 1/4, and then times by 3/4 to the power of 4, and that one is 3955, 0.3955. So I need a 0 and a 0. Now if I don't, there's some probabilities. The 0 probability is that, and means times a 0. So that sum is the probability of getting a 0 and then a 0. And then it can be or 0 and 1. So 0 and 1 is a 0 probability, and means times the 1 probability. Or the other option is a 1 and a 0, which is just those two probabilities times together, but the other way around. And because I said or, then I will add these 3 options together. And when you add those 3 options together, you get an answer of 0.2440. And that's the answer to part 2. And I realise that's not what is given on the left hand side of the official mark scheme if you have access to that. That is the answer to that part 2. It does appear over on the right of that mark scheme. And finally, part 3 of this question. We've now got 10 values of x chosen at random, so we've now got n is 10, and it says use an appropriate formula to find the probability exactly 3 are 2s. So we want exactly 3 are 2s. Well, I'm going to call this a binomial distribution, with n being 10, and I'm going to have getting a 2 as being my success. So my p-value is the probability of getting a 2, which we worked out up here to be 0.2637. So I'll call this another letter. I won't use x again because it's a different distribution. I'll say this is y. And y then is a binomial, sample size 10, and this is my success probability, the probability of getting a 2. And I want exactly 3, so I want the probability that y is equal to 3. Using your normal formula, it's n choose r, p to the power of r, and 1 minus p to the power of n minus r, 10 minus 3. That's the calculation you do, and the answer for that one is 0.2582. And that concludes that question.